Hello guys, welcome to my video on the etracer project. So today I'm going to show you the low line feature I added to the firmware, the software version 2.06 alpha. And last time I already showed you the program can calculate the output power and the voltage swing for the user. The only thing missing was the distortion calculation. So I spent some time to complete the distortion analysis, and I also refined the GUI. So let me show you how it works. So first of all, we can download a curve. That's previous curve. Okay, so let's use a 300B. Sorry, let's use a 300B for example. So this is the curves for the 300B. We can click on this low line tab, and we can see this blue line represent the load of the to the 300B. The slope is the resistance of the load. Okay, so this blue line is composed by several segments. The light dashed line is an extension of the low line. And if you look closely, you can see there are very light blue hollow circles on those on the intersection of the low line and the each curves. So these are the mathematically these are the solution of the points of where the low line and the curves intersect. So I display these points because maybe in a real case, because there's so many combination of curves. So maybe in a real case, the algorithm is so messed up, and the result is unreliable. In that case, you can see you can probably observe something wrong on the light circles. Okay. So the solid line is the where the user can configure this. The middle, this circle and this circle here are points the user can drag. So this the circle in the middle means the quiescent point for the low line, and this point decides the slope and the voltage swing of the output voltage. And this solid, this blue dash line and with this X mark is automatically updated by the software. So basically, when the user configure the parameters for this solid line, this part is automatically calculated. This solid line represents the half voltage swing of the play voltage. And the point where the low line intersect the curves represents the grid voltage. For example, if you move the endpoint here, it means the grid input voltage is will swing from minus 20 volt to minus 120 volt. So in total, the grid swing is close to 120 volts. Okay, so we can fix the load resistance, and for 300B we can put the 3.5K load on the plate, and we drag this endpoint and move the quiescent point around, and we can see the output power is automatically updated. So in this case, we can at this point, question point, the play voltage is 408 volt. The idle current is 87 milliamp. Under this bias condition with a 3.5K load, the voltage swing peak to peak. The half voltage swing, this part from here to here is 276 volt, and the bias point is minus, for the grid is minus 81 volt. The required input voltage on the grid is 162 pp, 162 volt peak to peak, and the output voltage swing is 495 volt pp, and the power output is 8.7 watts. Okay, and this row we can see the distortion under this voltage swing. The first entry box is the THD, the total harmonic distortion, and here in person. So here we can see the distortion is 6%, and we can see each component of the contribution of each component to the THD. This is the second harmonic, and the third, fourth, and so on and so forth. Okay, so we can see that the dominant source of distortion comes from the second order. Okay, and we can change the low line color. So if you don't like the default color of blue, you can always change it to something else. And if you are very disappointed with the color configured, you can always reset it to default, which is blue for the low line. Okay, so also you can use the keyboard arrow key to move this low line around if you want the finer control. Okay, so now let's use a 12AX7 for example. Okay, so for tubes that has come with the two sections, we can choose which section to analyze. So for example, let me turn off the one section off, and we focus on the red, the set of curves that's red in color, and as usual, we can move the load line. We can configure a different load resistance and check the voltage swing, power output, and the distortion. And we can select the axis, the source axis to the right, and we can now we can analyze we can do the low line analysis on the right curve sets. Okay, here you can see the light circle now are on the green lines instead of the red lines. Okay, so if we switch to the left, we can see the light circle now is on the red colored curves. Okay, so that's pretty much about it. And don't forget, I provide the save plot feature, so we can set the graph to various file format. Okay, let me save it again. Test. Okay. So this is the graph we saved. You can, as you can see, the low line and the markers are also saved. If you don't want to save the graph with the low lines, you can move to other tabs and click save plot. That way you won't save the low line information. Okay, that's pretty much about it. I hope you guys will love this new feature, and if you have any comment or problem, you can always leave a message at Facebook or email me directly. That's it. Thanks for watching my video. I'll see you next time. Bye.